Hi everyone, my name is Violetta Peterson, and I'm going to do a demo for Project 1 for the Operating Systems 2017 summer class. The objective of the first project was to create a simulation of CPU scheduling using three different algorithms. So we have first in, first out, round robin, where the user can specify the time quantum, and the shortest job first. So first I'm going to go into a little bit of the logic behind how I approached this project, and then we'll do the actual demo. So the input for this project was a file, like a text file, with the process ID, its arrival time, and the computation time, so how long it takes for the process to actually complete. So for the language choice, I used Python 3.4, and simply because Python is simple and it also has support for parsing text files like regex, libraries for reading user input in the command line interface, and the tkinter library to create the graphical user interface. So let's talk a little bit about how the processes actually get scheduled. So first we have a list of processes. And in our project, that's the text file with the PID, the arrival time, and the computation time. So once we have the input, each process gets admitted to the ready queue. From the ready queue, the process is dispatched into CPU, and in CPU it's actually being processed. So while it's in CPU, its computation time is actually running out. And finally, the process gets terminated. Now, for the round robin and shortest job first, we also have a preemptive function that allows the process to do a context switch from CPU back into the ready queue, and another process to replace it going back in through the, again, dispatching into the CPU. So, for example, in the first in, first out, a process gets admitted to the end of the ready queue. And then the first process in the ready queue is dispatched into the CPU, and once it is complete, it gets terminated. So it's very simple. For the shortest job first, a process gets admitted into the ready queue, but the ready queue is sorted by the computation time. So the shortest time is in the beginning of the queue, and it's the first process that will be dispatched to the CPU. And since this is preemptive short job first, if a process comes into the ready queue and it's a shorter process that's currently in the CPU, there's a context switch. So the process from the CPU gets transferred back to the ready queue, and the shortest process in the ready queue gets dispatched into the CPU. And this goes on until all the processes terminate. And finally, for the round robin with time quantum, a similar process takes place. So the process is admitted to the end of the ready queue. Then it's dispatched to the CPU. Now, while it's in CPU, if it still has time left, but we had the time quantum, then it goes back to the end of the ready queue. And the time quantum essentially determines when the context switch happens. So it will be the modulo of that time. So for example, if our time quantum is 4 and our time is 1, 2, 3, 4, at time 5, there will be a context switch. So, because all of these algorithms for the three processes actually look very similar to each other with a few exceptions, the way I organized my project was the following. So we have the basis of our project is the process, and essentially that's contained in its own object or data type. So we used class to simulate an instance of the class, to contain the data for the process, and that's your the process ID, it's your computation time, and it's your arrival time. So on top of that, we have kind of the back end, and that's the scheduler itself. And the scheduler has 4 different methods in it. So we have the admit, dispatch, terminate, and context switch. So all 4 that we discussed previously. And finally, at the very top, we have the graphical user interface or the command line interface. And those depend on how the user is running the program. So for example, if you run the executable file itself, the user will see the graphical user interface. But if you run the program from the command line, the user will have options to input into the program. So let's take a look how it goes. So let's first take a look at how our program runs in the CLI. So in CLI, we can have a few inputs. So the first is we have to specify the name of our program. Then we can choose to do a verbose flag, and we can select our algorithm. And finally, we can do the name of the file that contains our input. Once we do that, the program returns the verbose output, so it says what happens at every single time, the job number, and the state of the process. And finally, it also outputs the completion times of each process. So for example, if we were to do this without the verbose flag, and we can do round robin with time quantum 8, the program outputs the process ID and the completion time. And if we just test out the shortest job first, we get the output for the shortest job first. So it's very straightforward for the command line interface. And once we call the program from the command line interface, with tkinter, we have a few options here. So in the top left corner, we have a way to select our input and what scheduling algorithm we would like to use. The top right corner displays the results of the completion times, and the bottom actually displays the verbose output. So for example, if we were to schedule the first in, first out, and we select our file, and we click run, we get an practically immediate output for the process IDs and their completion times, which match our command line interface, and we get output for the state of the process at each time when the process is switching states. If we test out the shortest job first, we can keep reusing this file without selecting it. We just click run, and we get new results. And finally, we can do a round robin. Again, we can reuse the same file, and it changes everything. So we can actually specify the time slice. The default is 8 time measures. We can say, for example, 4 time measures. If we run that, we get a much longer verbose output because of so many context switches. And if we do, for example, 20, we obviously get fewer. And this, in a nutshell, is Project 1 CPU scheduling. And if you have any questions about it, I encourage you to shoot me an email. I would love to talk a little bit more about this. And thank you for your time.